Hello, this is Mrs. Brown with part one of the distributive property. We're going to start out by modeling a real-world example to see what this kind of looks like, and then we'll get into a lot more practice with the distributive property in the next one, okay? So let's start by reading the word problem. Cedric wants to cover 2 areas of his room with 1 foot by 1 foot corkboards so that he can display pictures of his friends and family. The first area is 4 feet by 3 feet, and the second area is 4 feet by 5 feet. How many corkboard tiles does he need? Okay, let's start by modeling what this would look like. So if we have, say, a 4 by 3 area, it might look something like this, where I have 4 this way and 3 this way. And I have a 4 by 5. So it might look something like this. And this would display, of course, 4 times 5 is 20 and 4 times 3 is 12. But if I were going to write what this total was, I would say 4 times 3 plus 4 times 5. If I was writing an expression to represent this total number, I would write it as 4 times 3 plus 4 times 5. And you again can see 12 by 20, and this is 12 plus 20, and so the total number would be 32, okay? Now, how do I write an equivalent expression? Now, you're looking at this going, I could write an equivalent expression using the commutative property. Sure, but I want to use the distributive property. Basically, what this is saying is when you look at this problem, this is a 4 and this is a 4, and in both cases, I'm multiplying the other number by 4. So instead of treating it like 2 separate rectangles, I could treat it like one giant rectangle that had 4 by one side, and the length of the other side would be like 3 plus 5. So I didn't really leave room for that, but I could see this as one giant rectangle. Okay, just making sure I have the right number there. Looked funny for a minute. Where this side is 4, and then I've got the 3 and the 5 together for a total of 8. And I could treat it like one giant rectangle instead. So what I would do in this case is I would say 4 times, and then I know I need to add 3 plus 5 to get 8, and that would be an equivalent expression. So when we're looking at the distributive property, you can think about it in kind of a concrete way, which means that you're looking at this as 2 separate rectangles that have one dimension in common. They both have a height or a length or a width, however you want to think of those, as 4. And because they both have the same number, I can actually pull that number out of that multiplication and add first and then multiply, okay? This is just a very basic overview of the distributive property. I'll do another one that gets a little bit more in depth, but I wanted you to kind of see the model of how you would do this. Again, I would think of it in this case as like 2 separate rectangles. In this case, it's like one giant rectangle that's kind of been squished together. These two are equivalent. And if you look at this, this is 8 times 4 is 32. This is 20 plus 12, which is 32. So they are equivalent. They equal the same thing. Okay. We'll do a lot more practice with the distributive property in the next video, but hopefully this is a good overview for you.